Alright, this video we're going to be talking about finding the domain of rational functions. And what a rational function is, it's essentially a quotient of polynomial functions. Now, rational expressions are quotients of polynomial expressions, and rational functions are quotients of polynomial functions. Now we could define it as, say, a function f of x is n of x over d of x. That's just some fancy notation indicating that there's some polynomial function in the numerator. We call that n of x, and it's the quotient, or it's divided by some polynomial function in the denominator, and we're indicating that by d of x. Now we can't divide by 0, so d of x cannot equal 0, and that's where we're really going to be getting our domain from, is this fact here, that you cannot divide by 0. So whatever causes the denominator to equal 0 is going to be part of our restricted domain. So let's do an example where we find a domain of a rational function. Suppose we had f of x equals 1 over x minus 1. So for this problem over here, if I'm going to indicate what the domain is, the domain for this problem is going to be that x cannot equal 1, because if x was 1, we would be dividing by 1. So essentially, another way to do this, what we can do is we can say, what makes x minus 1 equal to 0? And whatever this answer is going to be the thing that x cannot be. So if I were to add 1 to both sides, it's indicating that when x is 1, it will be 0. So whatever the solution to this is going to be what x cannot equal. Now some students get confused with the fact that it says x equals 1 here and x doesn't equal 1. Well, this is an indication of what x value would cause a 0. This is indicating what x cannot be because of the denominator becoming 0. So let's look at b here. Say if we had 3x squared over x squared minus 1. So for this one, what makes x squared minus 1 equal to 0? Well, if I add 1 over and I take the square root of both sides, I get the positive negative square root of 1, which is positive negative 1. That means that my domain for this problem is as x cannot equal positive or negative 1. Because if it was either of those, we would be dividing by 0. Let's do one more. Let's say our function was x over x squared minus 5x plus 6. Okay, so on this one, we have to find out what makes x squared minus 5x plus 6 equal to 0. Now this can be factored. We have an x and an x, a negative 3 and a negative 2. Two numbers that add up to negative 5 that multiply to give me positive 6. So when x equals either 2 or 3, it will equal 0. And we can't have that happen. So that means the domain is x cannot equal 2 and x cannot equal 3. So that's essentially how you find the domain of a rational function, is whatever causes a division by 0, I'll go back up to here, whatever causes the denominator to equal 0 needs to be restricted from the domain. You need to make some kind of statement saying that x cannot equal that. We'll eventually find out in the next video, where we look at asymptotes and wholes of rational functions, where when you look at a restriction, for example, when x is 1, for this problem over here, x cannot equal 1. So what does that mean in terms of the graph of the rational function? What will it cause? So we'll talk about that in the next video.